welcome everybody. I hope you can see my screen, if I get a yes for that.
Yep, it's good.
Perfect, awesome. Yeah, thank you for the invitation. My work has a lot to do with technology, science, and mathematics and all of that stuff. So it's a pleasure to present here. I'm very well known to the STEM and the STEAM field through like sort of educational use and all of that stuff. And it's a really good initiative, of course, from multiple sides. So my background is I'm a fashion tech designer, so I combine fashion and technology. And how I do that is on the body, and I use robotics. So I'm using a lot of like hardware, software, and I'm going to tell you something about that. So you can find me on online. Just look up my name, and you will see things pop up. If you have a question, just write it in the Q&A section of this Zoom meet. So if there's any questions, then we go over that later on. So my work is existing of what I already say, sort of robotics on the body, and I use a lot 3D printing. In prior times, I use sculpting. So I come from a little bit of sculpting background, design background, and my main background is fashion design. When I was 14 years old, I got into that. And when I was 17 years old, I got into robotics. So how that looks like is this, for example. This is the robotic spider dress. I was working at Intel, the semiconductor company, in 2014. And I was working with Intel Edison, which is like a platform that they created for makers and people like designers and innovators and engineers. So what I did was I was connecting my ideas to it, like see what I could do using the Intel Edison as a base module, and what I could compute over sort of. So one of the dresses that I created, and I created about 6 dresses and a few devices for them, was the spider dress. And the spider dress was being released at CES, which is a big technology trade show in Las Vegas every year. So this is the spider dress, which you can see. It has, let me see what is going on. Okay, it has mechanic legs on the shoulders, and they are 3D printed, and they are servo based. So there's like little motors in these in each of these legs that I then can animate using computer language, which you can see here. So what I'm using are ultrasonic rangefinder. So I'm measuring up to 25 feet. And when people are coming in the direct surroundings of this dress, the dress is attacking. And the dress is not attacking in just one way. It's reacting in something that I call 12 states of behavior. So depending on how you interact with this dress, the dress is reacting differently. So what I'm using is the spaces around the body. So the intimate distance, the personal distance, the social distance, and also the public distance, or the public space. And all these spaces have different measurements almost, you know, depending on culturally, like emotionally, spaciousness, sort of, you know, there's a lot of psychology behind that. So, depending on how you interact with this dress, it's and do so because not So the dress itself is a former version has been laser cutted. In this version, because the one I'm going to show you later, it was based on plexiglass, laser cutted, and it had a lot of screws. And every time it started to animate, it started to drill out those little screws. So definitely for this design, this project, I chose to use 3D printing, and I'm using a technique called selective laser sintering, which is a sort of a powder printing process that I'm using a lot because it's very rigid. So here you can see some of the design of the dress. It has this bone-like structure. It uses the eyes of the spider where the sensors are in, and also in her underneath her ribs there are 2 respiration sensors. So it's also doing sensing of her own emotions as well through that in this almost kidney shape. So here you can see some of that process of modeling the dress. So first of all, it's important to have the dress being stable because of all the servo motors on the shoulders, so that should not wiggle too much. So it was important to really get a good angle how the dress and the shoulder pieces are mounted on the body, like really almost like an exoskeleton. So this is some of that design process in steps, how we did that. We took like body scans of the model from that human body, starting to create the first layer, second layers, third layers, fourth layers, and all of that stuff. And here you can see a little bit more of the conformation around the body, because especially if you're working with really rigid materials, you want it to fit nicely. So that was a big part of that process. The spider dress also came with little spiders that were like following the dress at CES. So that was kind of cool. It was a little bit coined at Makers and the Maker Faire. Later on, we used them at several maker fairs to teach children coding using these dancing spiders, because with the dress, that's a little bit harder to do. But the kids really liked these dancing spiders. So we took them to like little platforms during maker fairs, which are, of course, a lot of fun sort of. And children would be able to like interact with them, like to program them or to see them dance and get some more information about that. The system itself, you can also see the Intel Edison in there. Sometimes I like to show the electronics, and sometimes I like to hide them. And here definitely it was a project to show more of that hardware, sort of the visuals, using all these cables, using all the wires and all of that stuff. To also make it very easily to explain, for example, to our nieces, to my grandmother, you can exactly see where all the wires go and how that's connected. So sometimes I choose to show a lot of these electronics, and sometimes I like to hide them, sort of, that's just an almost a design decision in here. So I started when into the beginning of 2000. In 2000, I was like connecting big computers to the body, which was not always super sexy. So in 2004, 2005, the guys from Arduino came out with these boards, and I got super enthusiastic. And David Corvallis, I cannot pronounce his name correctly, but he went to Sweden, and I followed him there. Like, hey, you guys have something that I need, that I want to work with, And ever since I've been using like open source electronics, or this is a prototyping platform that you can more easily program than another language like C, C++, and Python and all of that stuff. So if you're interested in getting into coding, like Arduino is a really nice, gentle platform to get into that. It has its own language, and the language is pretty simplified, sort of, So for all the stuff that I show you, almost all the stuff that I'm showing you, you can basically use Arduino. I'm using Raspberry Pi Zero Ws for more camera related stuff. If I do like facial recognition or whatever, anything connecting a screen to it, you can use Feather. You can make your own controllers, or ATtinies or whatever, So there's a lot of possibilities in making robots move and all of that stuff. So this is the some sketches from Arduino. So it's an easy way to program it. So, and it's also open source. So I think like what Arduino did in half of like 2000, they really made electronics to be fun, to be accessible. And that was a time that computers were more difficult to work with, so they really came in to bridge this gap between sort of computer languages and working with hardware based on that, and making their own boards that were easily to program. So I love them very much. So what I'm using is basically my laptop. I'm using like sewing machines and machines to create, construct, and to produce. Soldering station set up to construct, compile, engineer. I'm using 3D printers. I'm using laser cutters. I'm involving myself a lot with like new manufacturing methods, because I just like it. I like it from a maker and a build kind of sort of angle. So one of the other projects, and this was the first fully 3D printed dress that I did, and that was in 2010 with a friend of mine. He's an Italian architect, Niccolò Casas, and together we were trying to figure out how to use Maya and how to create a fully a full dress out of that using SLS, so selective lace sintering, by which you have a lot of allowance, you have a lot of freedom in your shapes and your geometries. It also has a lot of more problematic things. One of the things is the bounding box, so you cannot sometimes not print a full dress out of in one print. So what you see here, the smoke dress has been printed in multiple parts and then basically glued together, and that was in 2010, 2011. So the smoke dress is based on an octopus, and it has sensors. So it has, in one version, it has infrared sensors, and in the other, it has ultrasonic rangefinders as well. And other than the spider dress, seeing just one person coming into the space and reacting, this dress is measuring how many people are in the direct surroundings of this dress, and then it starts to evade smoke. So that's the smoke dress. So you can see it here in my studio. I was doing a lot of testing with low and higher hanging smoke. It's a silicon-based smoke fluid and then a system with hot nozzles that I'm pushing out. So in former versions, I'm using other things like dry ice, for example, and a drip system. I used big smoke machines until I think this is the 6th version in where I'm using a 500 gram system in the end, which is like sensoric and also reactive. So this very organic dress, when the spider dress is much more like out there, this deep V shape. This is a very elegant, very almost pear-shaped design. So here you can see some of the build-up of that model. Working almost with like these outer lines, and then working with a fill-in. The space needed to be in the hip area. That's where the smoke goes in, turns around, and then is being pushed out through this little grid-like 3D printed sort of mesh. So what we're using is TPU to incorporate thermoplastic polyurethane. SLS technique, so the selective lace sintering technique, that is flexible until a certain degree. And this was like 8 or 10 years back. Now they improved that, but that was definitely an interesting thing that came about, that we could not only 3D print in solid materials, but that we also could print in flexible materials. So this was a project for Volkswagen, and that was became a big show of 8 pieces during IAA. That's the car show, a big car show in Germany. So that one was almost, I think the Volkswagen collection was like 10 years ago. And I think for me, it was really like figuring out how to get those designs running and having them also run for multiple days, because it was a 3 or 7 day show, and they were showcasing 6 times a day, the same show sort of, so the music started, they started to walk, and they did that whole show of each was, I think, like 3 or 4 minutes or something like that. So getting the designs to run for a longer time, and also having them controllable and working on the music. So at that time I was using XP, so Zigbee, and then doing that over the DMX system of the lights actually. So that was kind of a cool way. We also did that in Los Angeles for the Super Bowl as well, to use another sort of sort of another sort of module than what I would normally have done to do this way. So another dress is the Drinkbot dress, which is this one, and it's a robotic cocktail dress. So it's created for Cirque du Soleil, and Cirque du Soleil, you know, from the theater, but they also have a restaurant in Ibiza called Heart Ibiza, and they asked me to create some food experiences that happened within the dress. So the dress itself has a peristaltic pump and a little button, and when the server is pushing on it, the drink is being created. It's gin and tonic, and the girls were like walking through the restaurant. At this point of time, we also have boy designs that are coming out soon. And there were also like some other designs that I created for them. So this is the peristaltic pump from Party Robotics, an open source robotics and peristaltic pump company that I was using. And here you can also see some of the other things was like bubble gum on the shoulders that was pushing out the bubble gum. And we did some like food experiences around that. So my work is mostly based on, even when you put technology on the body, what does it do? So how can it become social and playful? How can it become defensive and behavioral, or expressive and sensitive? Like, what does it do? What is the dialogue in there, you know, and how is the technology helping to create that interaction between the body and the wearer and the audience almost. So really seeing fashion as an interface. So these spaces I already talked about. There's two things that I do. I sense the spaces around the body, and then the other thing is I sense the body itself using body sensors. So if you're talking about sensing the surroundings, again, using these spaces and all of these spaces having certain measurements, it's called the theory of proxemics. And Edward T. Hall in the 60s, he defined this field. He created sort of a little research for himself and a book called The Hidden Dimension. So that is a little bit where that notion comes from, that he started to notice that different people and different cultures have different like personal spaces, you know, so he started to write about that. And he was measuring this with a stick, like an analog stick, you know, as he was going to different cultures and different social meetings and gatherings and all of that stuff. So basically what I did in the beginning or half of 2000, I started to take his research and correlate that to what digital means, what he was doing analog. I was trying to recreate digitally using my sensors, so ultrasonic rangefinders, infrared sensors, and all of that stuff. And then the other thing that I do is use body signals. So I'm using EEG, so brain signals, pulse, EMG, so muscle contraction, galvanic skin response, respiration, lung volume, accelerometer, so place in space or your movements, heart rate and heart volume, and temperature, and like a bunch of other sensors. So I'm also sensing the body. So some of the process, and this is the design of like 15 years old. I think one of my first designs that I was busy with this stuff. It's called Pseudomorphs, and it explains a little bit step by step how my process is basically going. So the first thing that I have is like a fascination for something. So in this project, it was the dance that a drop of ink makes in water. So I think that's a very elegant kind of thing. And I wanted to translate that to a dress, to this notion of like, okay, how would that look like in a dress, like imagining it. So mostly I either sketch or I use Adobe Photoshop to create like a little bit like the design. At that time, that was 13 years back. Now you can go from there into like 3D modeling software or whatever it is, sort of, especially with mechanical stuff. You can go in CAD directly, sort of, you know. In this case, I was looking at a lot of like things like tubes and actually running to the hospital to see what I could find there and how they could help out the local hospital. I said, like, I want to do a project with solenoid valves and I need a lot of tubing and I wanted to research that. So they gave me a whole box and I still don't know what everything is, sort of. But then I ended up with these Festo solenoid valves that I'm pulsing basically the fluids through it. So normally this is used for air. I'm using them not correctly. I'm using them for fluids because at that time they didn't have fluid waterproof solenoid valves. They only had the air ones that they were using and selling. So basically that's the system based on these solenoids. false. It was an artist in residency at V2 in the Netherlands, which is a really cool institute for new media. And I was there in 2010, and basically one of the things was to make it run on a small battery. This was at that time a 9-volt battery, and to make the system as small enough and later also like waterproof enough to test with this. So that was the first step. That was my first time that I was busy with Eagle, Autodesk Eagle, and V2 was helping me with that. So at that time it was still Eagle. Now it has been bought by Autodesk, the company. So that is a PCB design software that you can all download, and like I guess it's free, but you need to check it out. It is if you want to create your own PCBs. It has like libraries that are connected to the Mastercard and all of that stuff. So the whole idea was that the rest would have that feel of that the ink falling in water, which of course I cannot really recreate. But how I was recreating it was by using chemicals within the dress, and then dropping the ink on the dress, and it all created these different kinds of patterns because of the ink was flowing over it. And that was a project for ISEA, and then all the dresses were around. As soon as there was a new dress ready, it was being hung around the model, so there was kind of an installation kind of thing. And then also we used it for Britney Spears in one of her clips, Hold It Against Me, only we used a really cheap fabric for that, so the ink stains didn't really go in really well. I was using a wool felt for it, which would become really, really heavy, sort of, you know. And we also used a pressure system and having it all spray out of her hands because it's Los Angeles and they like that stuff, sort of. But so that is how Pseudomorphs, that notion came into this clip in a whole different way. So in regards to prototyping, one of the important things is prototyping, and that's also what you do a lot if you're creating like a design, you want to see what it can do, also what it cannot do, sort of. That is always really important, I think, to understand the limitations and also the possibilities. So what I always do is stretching the material as much as I can. So this is a PDLC, so polymer dispersed liquid crystal, which at that time, that was 2010, around that time as well. Was not that known. Now you use it a lot in between glass too, so it's not that fragile, sort of, you know. But at that time there were a lot of companies making this material, and they did not know what to do, you know. So they were interested in maybe it can become something for architecture. And so I was working at that time for Studio Rozengaarde, Daan Rozengaarde, on this project, and he showed me the material, and he said like, what can we do with this, sort of, you know. So what my first step is to see how it can conform and how I can create all these shapes without it being sort of pushed through. In the upper part where I'm holding it, you can see that the liquid crystal is condensing a little bit together, so it creates little like bruise spots. So that teaches me, by making such abstract objects, it teaches me what the material cannot do, almost, you know. And then you can work on what it can do and what you want to make with it and how you can make it durable and wearable and all of that stuff. So this became Intimacy Black, which was a dress based on the heartbeat, and it started to be more and less transparent as it went. And then also seeing how it can go on the body, and also how it can still do its thing on a doll, for example, as well. So we created a little interface that could connect to that while the dress was in an exhibition setting. So here you can see some of the material, some of the sort of the conductors at the side of the material, some of the shape research, and then this became the final piece. So you can look it up. It's called Intimacy 2.0. But that's a lot about like material research. Like again, like what can it do versus what can it not do. Then also like research and design is, for example, that I work in version. So what I already talked about is the smoke dress of 2007 doesn't look as the smoke dress of 2010 or 2012, you know, because I get new manufacturing techniques, new design techniques, and new technologies and all of that stuff. stuff. So other than just creating a piece and having it be that piece, my designs almost have like versions, like version 1, version 2, version 3, and so on. So this was the smoke dress of 2007. An earlier version, 2005, was a system with what I said, a drip system with dry ice. It was dripping on the dry ice and it was creating that smoke. So that was almost the baby smoke dress, and also the spider dress has been a baby before, and the spider dress is actually based on a game called Limbo. And I don't know how much of you guys know this game, but when I saw it the first time, I was just freaking out because I think, yeah, it's so simplistic, and the music, I think it's a French game, if I'm correct. The music is by a guy from Scandinavia or something, but the main figure is really being led through music, sort of, you know, and side scrollers I kind of like, but I really love this abstraction of what they did to the game. It was very artistic, very eerie to me, you know, so I really like that. So it's called Limbo. If you don't know it, you can play it. But there's one scene of this little boy, and the little boy is walking, and it encounters a spider, and the spider, when it goes to the spider legs, it attacks. When it walks away from it, it stops, you know. So you need to, of course, yeah, go for it, not get killed, sort of. But this sensoric notion and the relationship between the spider leg and the boy was really of interest for me. So that actually started the spider dress in, I think it was 2011 or something. And then what I do mostly is I need to know if the ideas that I have in my head, this notion of like reactivity between and the co-companionship or the relationship between these spider legs and the human. How that also looks mechanically. So what I mostly do is cardboard. I start with cardboard, making a little like mechanism, or especially in the past now, I might do it in 3D, for example, but like a little mechanism with like little string pulley things, and making it move that way. That makes me understand if I like this movement, if I like the leg, if I like the size of the legs. And of course you can now also do that in 3D modeling tools. But that's a little bit how I mostly start that process of figuring out the mechanics, often asking friends over if I can see it also on them, sort of, and yeah, that became the spider dress that I created in 2011. That is based on Limbo, which later became the Intel Edison based spider dress. So here you can see the system. So in robotics, we talk about degree of freedom. So the more degree of freedom your robot arm or something like that has, the more you can do with it. And especially I connect it to behavior. So the possibilities of making, like creating behaviors from, in this case, like quick and aggressive to more elegant to more, whatever, you can feel where they go up and down. So basically, the more behavior you can, the more degree of freedom you can have, the more like sort of kind of behaviors you can create. And also those spider legs, of course, lend themselves to already like understate some kind of like feel or eerie feel when you see it, sort of. When you walk up to the spider dress, you already know that something is going on. So when you interact with it, the same is happening because it's really attacking you. So that's about the relationship between like you, the approacher, and the wearer, or the system almost, you know. So that's a big part of like interaction design. So I studied fashion design, couture tailoring when I was 14 years old. When I was 17 years old, I got into robotics through the study of interaction design. So that's all about like, how these systems can interact in this case. And that, of course, yeah, from that laser cutted version, sort of it became this 3D modeled and 3D printed dress later on with Intel. What I mostly do is if I have a fascination for something, then I'm like writing down sort of research topics. I am like, yeah, then starting to work on the style, figuring out what kind of technologies need to be used. At that time, I was using a lot of Teensys created by Paul Stoffregen in Portland. He created from pretty early on, like really small modules in where Arduino is a little bit bigger. His modules were always, yeah, pretty small and really good for, yeah, for prototyping. So the last topic that I'm talking about is open source. So open source is a big yeah, thing in our field, like the internet's open source to Arduino, what I'm using, to a lot of people and makers and creators and designers and all of that stuff, putting their, and developers putting their stuff online. And that's really important, I think, because you can yeah, share what you have, what you may not use, and that you can maybe educate somebody else from that, maybe yeah, create a project based on that. So that's always important for me. So one of the cool things was that the spider dress, when it came out, there was this yeah, a group of students from Vienna, I think it was, and they created, recreated the spider dress. So that's kind of the cool thing, you know. So you create something like it was 3D printed, it was based on electronics, and then these guys take Lego as their medium, which is a really hard medium to create in, sort of, you know. And they started to rebuild the spider dress, which I thought was really cool. So you can see them having the ultrasonic rangefinders, you can see the system of the back. So they really looked at yeah, how the spider dress was built, sort of, you know, and then they sent a picture like, hey, look what we did, you know. And I thought that was super awesome. And they really created, like, tried to recreate what they could, this system. And I do not have a movie of it, but it's pretty cool. And then also when I brought out the drinkbot dress, so the dress based on the peristaltic pump, they also created that, and they presented it at Robo Exotica, which is a cocktail festival in Vienna. So that's kind of cool. Yeah, feedback from the community, not saying like, oh, that was cool what you did, but hey, look what we did, and we used Lego for it, you know. So that's kind of the cool. Yeah, that's the really cool part of the community, and like, yeah, especially open source community almost. So yeah, open source is make and share with your community. What you can use is like GitHub for source for code, and all of that stuff, any projects that you're using, yeah, computer languages for. You have Thingiverse for 3D models. Maybe you make a ring, you know, or some small part, and you're like, okay, I'm not using that. Or we all have like stuff that we have on our computer that we're not using. Maybe upload it and make somebody else happy with, that can print it out on their 3D printer as a test or something like that. You have Instructables, where you can find things from how to make tomato soup to how to make a robotic dress. Some of my projects are on there. Hexer.io is a little bit more hardware specific. So if you're into hardware and building things with hardware, yeah, go to Hexer.io. Also, I have some projects on there, and also OpenBCI community. I haven't talked too much about that, but I do a lot of things with brain-computer interfaces and brain signals, EEG. And there's a whole community of people that are creating their own BCI, so brain-computer interfaces. So that community is called OpenBCI if you want to yeah, look into that. So I have been more active on Instructables, but how it looks like is like there's a few of the projects that I showed. So the cocktail dress is on there. A crazy project with Tesla coils, making your own Faraday cage dress. And yeah, some things are on there. Mechatronics, Lego, Mindstorm wings. Also Hexter, you can make light up kitty ears that I uploaded there, so you can download it for free. The code is there, the PCB files, so the Eagle files are on there, so you can yeah, create these light up kitty ears. So basically the hardware components, the software, the sort of the tools and fabrication stuff, the story behind that. And it brings you basically through yeah, how to do this. And I use this a lot in workshops for yeah, teaching people to like solder and code, especially also with children, for example. It's really fun to do sometimes at maker fairs. And I bring these boards, and then like basically we're soldering up the boards, and we go through all these steps, and then we all make photos in the end with kitty ears. So that's kind of really cute. So if you want to have like a beginner kind of project, this is kind of an, yeah, a thing that you can find online to start with. Another little bit more difficult project is also in Instructables. It's an illegal build of Lego. So you have legal builds which are not stretching any of the materials, or you have illegal builds in where I'm stretching a little bit of the components to make them fit. So this is definitely an illegal build, but they are also step by step on Instructables project from 2014, how to make these. And I have a little video.
Just a couple more inventions to share with you now. These mechatronic wings won't help you take flight, but they will make you look super awesome. They're made out of Lego, and they've got infrared and ultrasonic sensors that are programmed to react to objects that come near them. The sensors work kind of like bats, bouncing high frequencies to detect objects up to 2.5 meters away. I kind of want these things. And the good news is you can make your own. They're the work of fashion tech pioneer Anouk Wipprecht, and she's recently posted a step-by-step guide on how to build them. So just head on over to our Twitter feed and you can have your own mechatronic wing.
So that was some of the Discovery Channel Daily Planet show. So yeah, you can find them on Instructables. They're fairly heavy, so but it's definitely yeah, it's definitely a harder project to do, but you can do a lot with yeah, using other things like Mindstorms as well. So if you want to get into like playing around with electronics, I would say like buy an Arduino. So you can see here arduino.cc. The software is free. The Arduino is depending on where you are, between 10 and $25 or something like that. You can find, for example, yeah, controllers, LEDs, motors, all of that stuff on adafruit.com or sparkfun.com. These are both American companies, and they have resellers in a lot of different cities. If you're in the UK, you can look at Pimadoni, which is a really cute one. They have a lot of like cute boards that you can use, and that you can do all kinds of yeah, sort of soldering kits with. For other components, smaller components, more tacky, I would go to DigiKey. And also for like other parts, like hardware parts or tubing or something like that, I'm using a lot of McMaster-Carr at the moment, also a lot of Amazon. So you can find a lot of that also on Amazon. So that's with you within a day. So that's good as well. But definitely, like, yeah, Adafruit is one of my favorite sites to just get lost in. And they also have a wearable section. So I think they sell like lily pads, Arduinos, which you can use with conductive thread and conductive fabrics. So that's a little bit my, yeah, sort of my talk. I chose to present a few of my older projects because they're a little bit more like, yeah, make related, and they explained well how I use, yeah, different technologies almost. So I am gonna stop sharing.